Hello, Kay. Hello, Lina.
Hi, Victor.
Hello, Sarah. Hello, Stephen. And here is Lola.
Hi.
Okay. So let's wait a couple of minutes. So who is not yet connected? Boston. In case he decides to join, we'll give him a chance. So while waiting, you're welcome to log to launch mobile experiment, connect to Photon, right? And I was trying to avoid this waiting room, but it didn't allow me to. It gives me request that it should be either passcode authentication or waiting room. And I think it is waiting room is a little easier. Oh, Amir, nice to see you connected.
Hello, Dr. Killian. Thank you for accepting.
Okay. So we're just waiting for Boston, right? Everyone else is already here.
Dr. Cullen?
Yes?
When I run the camera for the Zoom while working and also on the Mobex term, I lost the screen. So I just will shut down the video while I'm working on.
Oh, sure. Do whatever is comfortable. Just when we are speaking, it's better to have the video, but when you are practicing, it's fine.
Or just sharing the work. Thank you.
Okay, yeah. So let me check if we are on recordings, because it later on one may need this. So we are starting. Thank you for excellent presentations on last Friday, and we are doing a little bit quicker than in previous years. So right now we are starting a new. Oh, hello, Boston. Nice to see you connected. And do you hear me well?
Yes.
Okay. Yeah, I'm not using microphone. Probably there is secondary microphone in the camera. So Boston, please launch mobile experiment, connect to Photon. Okay. So we are starting a new piece of software, and of course, some of the skills that you accumulated before will be used, but in some sense, it will be a dramatic change of the mindset. So it is the difference between new software and other. Like you remember, before you were practicing and presenting how to use Avogadro and Gauss U, and in some sense they were similar, right? So both allow to click and draw molecules, measure distances and stuff like that. The piece of software that you will start right now will be a little bit less user-friendly. So just giving you a heads up. And I'm very happy to see that Amir and Stephen are here, so they have some experience. If I do not have time to address all the questions, they may try to answer, and maybe their help and answer will be better than mine. So you have seen the YouTube link to one of the previous year's presentations, right? It is something that we all will do in about 3 weeks. And today I'll first show some slides and mumble a little bit of introductory words, and then do demonstration, and then we all will start doing some practical exercises. So in simple way, our goal is to be able to compute things that you already know about: the ionization, affinity, homo-LUMO gap, make density of states, and plot orbitals. So in this aspect, you have some idea what we are looking at. And we will look on the same material, titanium dioxide, so you even have approximate vision of what to expect. But the main reason why we are switching from Gaussian, which is considered as a gold standard for chemists, we are moving to a different software which is more appropriate for materials design and for solid state and for physics, so that we will be catching several communities. And if your heart is with molecules and reactions, this software can be useful in case you need to model explicit salvation, in case you need surface chemistry, in case you need reactions and dynamics of reactions. So there are pluses and minuses in each of them, and one of my goals is to make you more universal and to provide you with arsenal of tools that will be useful for one or another application. So before I go to slides and demonstrations, let me just tell by simple language that, or maybe let me try to ask you, what is the difference between polymer and a standalone molecule? Or would you like to try first? Just how would you define polymer in comparison to a molecule?
Well, like repeating units.
Excellent, thank you. Boston, any comment about how solids differ from standalone molecules? Okay. Yeah, excellent. Very good. Let me check with Lina.
We need to change the microphone, and we have a lot of noise.
Oh, okay. You want to say something? Can I start now?
So now it's turn of Lina to say, and then we'll go for everyone to speak a little.
So polymers is a repeated structure of similar units called monomers. And what's the difference between the polymers and the standard molecule? The difference is maybe the bonds, the type.
Excellent. This is a really great keyword. What's the distance between monomers?
Between monomers, the distance. It's just in terms of bonds, I think.
Yes, excellent. It's a perfect answer. Thank you. Okay, let's see who else is. Yes, I'm here.
Can you a little adjust the microphone? There is some noise, and I cannot hear you.
I do have a secondary microphone, but it may.
It's okay now. I think after changing the camera direction, it is okay right now.
I think that there is a microphone hidden in the camera, and
yeah, now it's working well.
There is another one, but it may create a feedback. So is it better now?
Yeah, that's fine.
Okay. Yeah, thank you. So let's check with Sarah. Can you tell? So you will be doing the clays for your project.
Yes.
So what about clays? What is specific in them compared to like solvated molecules? Just we continue the discussion. What is a key property? Why we cannot do clays in Gaussian from your vision?
I think the type of bondings are different from other materials, and also the charge maybe.
Crystal structure, maybe.
Yeah, the crystalline structure of these minerals.
Okay, yes, it's another good keyword, crystalline structure. So it deals with repeating units. Yeah, thank you, Sarah. Stephen, would you say any comments about like maybe summarizing what was already said about polymers and crystals? How strongly are they different from standalone molecules?
I'd say one of the most important differences between a standalone molecule, a monomer, and a polymer is that the polymer will be dehydrated compared to the monomer. It'll be missing 2 hydrogens or possibly 1 hydrogen, depending on how it's bonded to the other ones.
Okay, yeah, thank you. And what about molecular weight of monomer and polymer?
It'll be very slightly less than the equivalent of an equal number of monomers.
Okay, but one should compare equal number of monomers, but standalone polymer is infinite, like molecular weight is infinite, right?
Yes.
Okay, and let me ask Kea. Yeah, thank you, Stephen. Just Kea, will you share your comments and vision of difference between isolated molecules and polymers and crystals? So instead of speaking, Kea is typing polymer molecules are composed of large number of linked small repeating units. Laptop is not working. Okay, it is fine. Well, it is not good that it is not working, but I do see your. Now you can hear you.
Okay, you can hear
very faintly
right now.
You can hear you. You can hear you, but you already typed the answer. Okay, so thank you very much for addressing this question, and your answers are justification and reason for us to start new software. So it will be specifically addressing the features of polymers and crystals where similar repeating units of infinite lengths and infinite molecular weight are still treated. So we will focus on one repeating unit or maybe several repeating units, but with understanding that they are connected to their brothers and sisters, to other similar repeating units. Make sense? Okay. So I'm going to just go over slides and then make demonstration, and then we'll try to repeat this.
May I ask a question?
Please.
So for sure, Gaussian is not able to do calculation of the periodic model, right?
It's not right. Gaussian can do it, but it is less efficient. It is not designed. Originally, Gaussian was designed for standalone molecules. If you are really interested to do periodic boundary conditions, one needs to add the fictitious atom, which is labeled as TV. So if you look in periodic table, there is no element labeled TV, right? But in Gaussian, you can add an atom that will be named TV, which means translation vector. And instead of coordinates x, y, and z, one gives a size of the repeating unit in each of the directions. And to some extent, it will work. But there will be additional errors because when the software was created, the main goal was to adequately describe standalone molecules. Make sense?
Yeah, thank you.
Okay. So here is the tentative list of subjects for presentations that we will do in 3 weeks. And I'm going to show a couple of handwritten slides, which I was showing to my first graduate student about 10 years ago. But since then, I didn't do anything better. It did work. She successfully defended thesis and got the job. So I'll show this handwritten slides and then go more serious to type things. So the vast software that stands for DNA Initial Simulation Package is different from Gaussian in many aspects. But one of the aspects that in order to launch Gaussian, one needs to have one input file, right? That is called .com. And then, as Wolo was teaching us, if you have this .com file, you can, in command line, run Gaussian and get anything you want output, correct? So, in order for VASP to be launched, one needs 4 input files. And the reason is not to make our life harder. The authors of the software were thinking that in Gaussian, there is a mixture of several things under one hood. There is coordinates, spin, multiplicity, request whether we need to optimize or find infrared frequencies, basis set, method, number of memory specifications, like everything is together as a like one set. In VASP, one tries to be organized and chop each things in a separate file. And those files here are their names: postcard, in-car, K-points, postcard. And the first one contains only coordinates of atoms in the model. The second one, in-car, contains request what to do, like optimization, precision, data set. K-points is a specific file that we will for future, but it will be needed to answer questions that Boston was asking a month ago about K-points, direct and indirect semiconductor. Later on we will cover it. And PODCAR will be pseudo potentials specifying elements that we are using. So most for the 3 last files, I will provide templates so that our life will be easier. But for the first one, we need to learn how to create. And before, you may have obtained an impression that by using Babel command, one can convert between all formats. VASP is so specific that it's better to do it more manually because its format is quite crazy. So we pay high price for future benefits. And if in the next minutes you will feel irritation against either your instructor or against the software, you may maybe mellow your heart by an idea that if you survive skills how to use VASP, you will be able to use any software in the world. Okay. Here's one comment more. Yeah, right. Yeah, we will use special sessions so that everyone will select what to present. But thank you to those who already decided. So okay, and probably I can do better with years, but history shows that I cannot. So you see there is a box here, right? And there is a solid box and dashed box. So the idea of the VASP software that we create atoms located in the simulation cell, like the repeating unit, and then we copy this box with atoms and assume that it is replicated to the left, to the right, to the top, to the bottom, front, and back. So there are copies, replicas of our explicit model to all sides of our box. And I will return to this idea again and again. So if we practice this idea, then we need to return back to our discussion 10 minutes ago. I think it was a question that I was asking to Lina and Sarah. Let's try to refresh our memories. What is the distance between monomers? Remember?
Yeah, I said it's in terms of the distance of the bond.
Yes. So the replicas, the copies of the boxes that contain monomer should have additional space between them, corresponding to the bond lengths between atoms in the nearest replicas, right? And in preparing the input files for this vast software, the main challenge is to set up this space between the replicas. So I'll show how to do it, but I want to give you a heads up so that you concentrate and when it will be practical part to do it, so that you focus, concentrate, and realize that it is a true challenge. So it is the most complicated part in today's meeting and maybe for the whole next month. So just be prepared. And here I'm trying to show it, but I don't know how efficient it is. So if all atoms are localized in the smaller box here, then the actual simulation box should be a little bit bigger and should have a vacuum, empty space, which is assigned intentionally for bonds between replicas having non-zero value. Because if bonds have zero value, then atoms are collided and they have infinitely high energy. So it will be explosion, right? And I'll go to practical aspects very soon. I just want that we all agree on the principles. So another little heads up. In this class, in our next couple of months, I will use only rectangular boxes because it is much easier for human imagination. But in our research labs, sometimes some crystals, some polymers need non-rectangular boxes for close stacking of minerals. And VASP software is easily ready to do. So when we will go into the examples of the input files for VASP coordinates, the top part of this file will, before we start coordinates, will include 3x3 matrix. And typically in our class, there will be all zeros except 3 numbers on the main diagram. Generally, they all can be non-zero if we have like corrupted, crazy shape lattice. But we will have one rectangular. So it corresponds that we have 90 degrees between axes of the box. And these numbers here, AX, AY, and Z, will be sizes of this unit cell in each 3 directions. So if we are more like chemists and polymer scientists, we need to replicate the monomer only in one direction, right? But if we are solid state physicists, we may need to replicate it in 3 directions, right? So therefore, to be general, it gives opportunity to replicate in all 3. And then, I know maybe you're already tired to see my ugly handwriting, but I'll follow up with better fonts and practical examples. If one will look into the input file further, one will see a table with 6 columns. So right away, I can ask why 6? If we have each row correspond to one atom, and each atom has 3 Cartesian coordinates, then I would agree to have 3 columns or maybe 4 columns. But why 6? So here is the reason. First 3 columns will correspond to x, y, and z coordinate of each atom. And here I give you another challenge and heads up why Vasquez crazy. It will be not in, it will be in dimensionless coordinates. So it will be in so-called fractional coordinates, actual coordinate divided by size of the periodic cell. Periodic cell. Along x, along y, and along z. So each of this fractional coordinate will take value between 0 and 1. But when we will learn how to convert between formats, there will be a way to convert it back in our favorite angstroms or nanometers. And another 3 columns will be letters, either T or F. And typically we'll populate it with letter F, which means translate or thermalize. And typically we will not use letter F, but it means like freeze or forbid to move. Okay. I think it is enough. Let me show first slides what I will be doing in pre-made form, and then I will do demonstration. Then invite everyone to follow. So I apologize if it is boring, but maybe if I tell the story and then start practical, you'll just be able to see where the beginning was, the end, and plan your own methods. So in your previous homework, you were practicing oligomers of titanium dioxide. Right? And here is one of them with 5. Right? And it looks like all titanium are on the same line, and pairs of oxygens are going in the opposite alternating directions. So we can identify the pairs of titanium and 2 oxygens, titanium and 2 oxygens. So the 2 titaniums and 4 oxygens are kind of repeating, right? So it's 0 degree, 90 degree, and then again 0 degree, 90 degree. If I am not brave, I can start with describing not the smallest unit cell, but periodic cell containing of 2 unit cells, maybe 4 titanium and 8 oxygens. So I'm doing it with the following purpose. I want to go from oligomers to infinite polymer when it goes to infinite number of titanium. So I want to practice periodic bond cell. So first I will try to measure distances and identify the size of this green box and remove things away from this green box. So note that I will cut off 2 hydroxyl from one side and titanium and 2 hydroxyl from other. But the distance of the whole cell will be from first titanium that is included to first titanium that is excluded. Okay? And interestingly, after I exclude this titanium here, so please focus on my figures. So this distance between this pair of oxygens and this titanium that we will exclude is amount of vacuum that we need to add to periodic cell to avoid collision between these two oxygens and the next titanium. So let me repeat it because it is the most challenging thing. Do not hesitate if you feel discomfort. It's really counterintuitive. Once again, I'm going to remove this titanium number 9, but the distance between this titanium and two oxygens I need to memorize it, store it, and then later on add as a vacuum to the periodic cell. Whew. Okay. And I think, and then there will be a couple of commands that I better demonstrate. So if you accept this idea, then as we go, you do the rest success. Okay. So I'm going to do demonstration. If you, I did try it before the class. It took me about 15 minutes. But if I will be stopping and making explanations, it may take maybe up to 40 minutes. And then I will invite everyone to try to repeat things and we'll try to assist. While listening to me, the best thing if you try to immediately reproduce and do similar things yourself. And do not hesitate to interrupt me and request help. I will either join your seats in the class or ask you to share screen. Okay. So here is the goal, the last thing that I want to obtain today myself during the demonstration, and that I want to obtain every one of you by the in like hour and a half. If you reach to such screenshot, it means we fulfill the goals of the meeting. So this is the list of orbitals, their occupation numbers and energies. And by your experience with Gaussian, you already know what we see here and how to interpret. So it's like orbital number 32 with energy minus 6.9, which is ionization energy, and orbital 33 empty minus 3.6, which will be affinity, and the HOMO-LUMA gap will be about 3.3 electron volt. So if we will arrive to the stage, it will mean our goals are complete. Whew. So what do I do? First, I am taking the we do it in completely separate directory so that we have only one file so that there is no interruption. So, so there is a oligomer of titanium hydroxide. You did 5, I did 6, but it doesn't matter. One can anything bigger than 4 will work. And first, I want to open it so that we see what I'm working with. But so open. I have too many. Yeah, it is here. It is open. So you see the pattern of titanium and oxygen are setting in the alternating order, right? Little plate plane elements are following each other. Now I'm going to convert this file into PDB format because I do want to open it in JMOL. Doing this command, and just in case you are on Zoom, let me share it in the chat line to everyone. And since you are doing your homework, you already have the models, optimized models that should work. If you are not confident in your own models, feel free to borrow it from my directory, or let me know, I will forward it to you directly. Now, let's -T. I do have this PDB file. Now, I'm going to open this PDB file with JMOL. And I intentionally use older version just because I like it. But here is the command. And here is the file. So chat, paste. So here is the model with repeating units, and what is important for the next exercise. If I display axis, you see that all titaniums are arranged along x-axis. If in your model you do not see it, it will adversely affect the outcome. It may be aligned not along x but along y or z. And if it is not aligned, yes, if it is not aligned, one can rotate it using Avogadro, or I will share a code that rotates models. And if you do not want to mess with rotations, and by currently your model is not rotated, you can borrow it from my directory. I will share the link. So now it is time to make measurements. So measure distance. So since my periodic cell will be 4 titanium, I need to measure distance between five of those. For example, the first and the fifth here. Add to measurement list. It shows 10. I can make it bigger. So it's 10.8. And just to double check, I can measure distance between similar oxygens. Measure distance. So it will be slightly different, but of the similar order of magnitude. The measurement list. So I do see that size of the periodic cell will be like 10.79. Little error is fine. So about 10.8. Let me go back to slides and demonstrate once again why I'm doing so. So I need to identify the box that will repeat itself again and again and form infinite chain. And I measure the size of this box. Okay? So if you feel uncomfortable without this with these measurements, please let me know and request more explanation. It's completely normal. Do not hesitate. Or let me ask. Please confirm if it is okay, or if you need more explanations. Just thumb up, okay. Thumb down, more explanation. So I do not see requests for explanations. Okay, thank you for approving. Now I'm going to erase atoms that do not belong to my simulation cell. So I select the diagonal red cross, which corresponds to delete an atom. And now I can keep the first, remove this hydroxyl here, there. Then I need 1, 2, 3, 4, and then 2 oxygens, and then I remove the rest. Click, 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 click. And now I'm going to save it. File, save as. I will save it in the XYZ format, and I will call it titanium 4 oxygen 8 dot XYZ. So you see, if I would treat this model as a standalone molecule, it will be chemically wrong. There will be uncompensated bonds. And it is basically what Steven was telling, that polymer misses hydrogens in the terminal hydrogens, right? So here is the titanium, which doesn't have oxygens, which means it will be chemically active. It's like catalyst. It's not a stable molecule. Here we have oxygens that have only one bond, but there are no hydrogen. So it will be unstable chemical thing that will not work as a standalone. It will find someone to connect to. But if we connect these two atoms, let me bring their atom labels and numbers. So if you connect this 12 and 11 with atom 16, if I like make a connection from here to there, then it will become chemical state. And while doing it, the only thing I need to put correct amount of vacuum between them. Okay? So maybe before we go forward, I want to see such figure at everyone's display. I can do the whole demonstration, but then if I do not see, if you're following, it may become more complicated. So please try to arrive to the same figure, and I'll check with everyone. It's good, but you need to learn how to create it from scratch.
I just want to follow along more than work on it.
Try to do
I will
right now.
Okay, we're done.
Let me take the sheet. Very good. Okay, now let's No. Just a second. I'll finish giving.
I think you. Oh, you did. Okay.
Okay. So I made everyone a co-host. Okay. Now I will just go over the list. So Kaya, would you like to share screen?
Both section of
Okay.
so
We're
Professor,
good. No?
you showed the X is something like that before. So how to
Okay.
do?
Yeah. Let me offer you steps. So go to display menu of the JMO.
Okay.
Click.
Then.
Click on the perspective depth. Perspective depth.
Okay.
Click.
Just
remove this. Uncheck this perspective.
Okay,
yes.
I uncheck. Yeah.
Okay. Now go again to display. Display. Axis. Check axis.
Okay. Access. Yeah. Access. Check. Oh,
Okay.
now.
Okay. And also go to display once again. Display.
Yes.
Atom labels. Atom labels.
Atomic
atom
similar,
numbers.
Atomic number.
Yeah.
Okay.
Click.
Yeah, I already clicked.
Okay.
So it seems like that it's similar to Gauss view. Like there are
Yes,
some
but
options.
it is only auxiliary tool. It's not the VASP. It is one just JMOL is a tool to measure and remove atoms.
Okay.
We are not yet in the actual program.
Okay.
Okay, so now please measure distance, maybe from atom distance. Yes, distance. Maybe move it a little to the bottom slightly, so that we can view the atom. Yes, and now click on the atom number 1.
Where
Click
is
on the
one?
click atom number 1. Click more confidently. And now click on the atom number 15. 2, 3, 4, 15 at the end. Yeah. Click.
Yeah.
More confidently. More confidently. Click.
What happened?
Try once again. Just click confidently.
I don't know. Sometimes what happened with my laptop. Just a minute. Ouch. I clicked.
Okay, let's do it over. Cancel measurement. Click on the cancel.
Okay.
If the internet is slow, you
Yeah,
may
internet
try.
is slow.
If internet is slow, then you may disable camera. It can give you.
Okay. Yeah, that's good. That's the thing.
But you need to click on 2 atoms to measure distance.
Okay, just a minute. I got.
And if JMOL stops responding, you can close and reopen it.
Okay. Well, still now it's not working.
Kea, maybe if you disable camera.
Okay, I already disabled the camera.
But you can disable it on the second laptop. It still takes your bandwidth.
Oh, yeah, that's true.
Okay. Now, maybe just close JMOL completely and reopen it. If you go to command line,
Maybe my laptop stopped working because.
No. Just go to command line of the mobile extern.
Oh, okay.
Click cancel here. What is? Yeah, here.
Yeah, it's already canceled.
In the mobile extern command line. Type kill.
Q.
Kill, not seal, but kill.
Oh.
Kill like bad
Q.
action. Not Q, but kill.
Can you spell it again?
K.
Oh, K.
Kill.
Kill. Kill.
Space. Kill. Space. -9.
-9.
Space. And then we need to repeat numbers of these processes that you see in previous line. 3, 6, 3, 5, 6.
Which one?
Just previous one line above. Just type 3, 6, 3, 5, 6.
3, 6.
3, 5, 6. Space. And then previous process 3, 6, 2, 5, 0. Enter. Okay, so you killed JMOL, and now do arrow up once. Arrow up. Yeah, and now hit enter. Yeah. And just practice patience. Wait, it should come up.
It's loading.
Yes, it is a little slower because we all are using it on the same server. So we are risking to lose the mercy of the system administrator. So while it is loading, can you click back to the command line? Click inside the command line, click.
Yeah.
And type PS, enter.
PS, enter.
PS. Yeah, you have only one instance of JMO. It should work. On your screen, okay, let's just.
What should I do?
Those windows should be closed. Close them. Yeah.
I'm not able to close those ones. Let me try.
So it is zombie process.
Yes. The previous one.
So maybe you may try to completely exit
Overtext?
exit from Photon, re-enter, and then try over again. And then I will while you're doing it, let me talk to others.
Okay. Then stop sharing.
So in the command line, exit, completely exit from Photon, and then re-enter.
Okay, Professor.
And please stop sharing.
I already stopped sharing.
Okay. Yeah. Okay. So Sarah, would you please share your screen?
Yes. Professor, how to delete the atoms?
I'll tell you in a minute. But so the distance between 5 titanium atoms is 10.8, right?
Between the molecule, the atom number 1, and then the I think the last one, this one.
Okay, please record this number on a piece of paper or in another window.
Yeah,
we will need it later. It will disappear from the screen, but we will need it later. This
okay.
10 point. You did. Okay. Now on the top of the menu, you see extras and you see diagonal cross. Click on it. Confidently click. No, not extras. Below extras.
Which one? This one?
Yes. Click. And now try to click on, let's say, hydrogen number 22. Click. And now keep erasing everything that you do not need. Click.
Should I erase this one? This one? Until this atom number 1.
Keep number 1 and erase and erase this oxygen number 6. Okay, now let's go from other side. We need to erase titanium number 15.
This one?
Yes. Click. And these hydroxyl groups. Okay, and now go to the menu and make file, save as.
Here.
Save as. And right now you're in my directory, right? Go to your directory.
I think it's my directory. I copied your files to my directory.
then you need to give unique name so that it will be so. Just call it titanium or yeah, I see. Good.
Yeah.
So call it titanium 4 or 8 test, something that you recognize it different.
Titanium.
Just give it a name.
Yes.
Something. Yeah. Dot XYZ and click use file extension, uncheck the box. Okay, and click save. Okay, I think you're fine. So you can stop sharing.
Thank you.
So Amir, is it okay if we skip you?
Sure, I did with Sarah because I do not have access
Okay.
to.
Okay, that's fine. Steven, would you like to share a screen?
So I followed the directions, Professor, but I actually wasn't able to view it.
Oh, just we'll figure it out together. Do not worry.
Right.
Just share screen and I'll watch what you do, and I hope you'll be able to.
So, I can switch to mobile XTRM if you need me to, but this is what I was working
Yes,
with.
because it allows graphical tunneling.
Yeah. Save the
So CD slash scratch 001.
help if I could spell.
SCR, yeah. Hit enter, or whatever it's comfortable with. Now again, C 2021.
So I also copied the files from your directory.
Okay, that's good. That's good. So let's open this titanium 6 DFT with JMO. So tilde slash, no, not goes with JMO, tilde slash uppercase JMO, not, yeah. Everything should be uppercase. J capital, M capital. Now slash lowercase JMO. Raise, yes, lowercase JMO dot sh space titanium 6 and name of the file DFT ampersand shift 7. No, it was good, DFT, and now just add this, yes, enter.
It's loading.
Okay. Is it loading to your other display?
Yes.
Okay, yeah. So what I'm showing now, I'm just sharing how I do it. But if you find more creative way to erase atoms with Gauss-U or in text file, I'm fine with it. So what I'm showing just seems optimal way from my point of view. Is it done loading?
No, it's setting up file choosers is what it says now.
Oh, I see something appears. It's okay. We'll do something. Just repeat the last string. Repeat the last string. Remove the file name. Just launch JMO, and then we will browse and open it. Yeah, hit enter.
And the ampersand or?
Yes. Keep ampersand so that whatever. It's safer. It's yes. Ampersand allows you to keep typing in this command line. If you do not do ampersand, it blocks this command line from further commands.
Loading again.
So let me check who we didn't done with this winner. Okay, now let's go to yes.
One thing that after selecting two atoms, I'm able to see the X, Y, Z.
Okay, we will return to your case. Let's do Stephen. Do not do it. Do not do it yet. Let me finish case with Stephen and then go to the rest. Okay, Stephen, click OK. Okay. Click Open. Open. Wait. Do not open. Click on the 7 lab on the top. Yes. Go to here. Click. Go to my directory. Yes. Click. Double click. Go to lab 7A, not 7B, 7A, and find the file that you are titanium 6 DFT opt PDB. Yes. Open. Okay. Now maybe enlarge it a little bit. Okay. So display. Let's bring compact. Uncheck perspective depth. Check axis. Go back display. Check axis. And go to display. Display. Atom labels. Atom numbers. Slightly do not start erasing. Slightly rotate, drag and drop, so that just rotate it a little so that we see it from different angles. Yeah, enough. Now let's go to measure distance from atom number 1 to atom number 15. Click. I do not see this panel for measuring. Did it? Okay. Add to measurement list.
Add to measurement list.
And do you see the number if the font sufficiently big?
Yes.
So please record this number on a piece of paper or in a separate file. You will need it soon. Now select this deleting tool, this red cross on the top. And start erasing atoms. Yes, 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 yes. And now from the other side. No, number, yes, hydroxyl. And this 15, yes, remove. Now file save as, not open but save. File save as. And now let's navigate to your directory. File save as. And let's navigate back to your subdirectory. Yes, Steven 7 Lab. Good. And just call it titanium 4.xyz. Uncheck use file extension. Sure, and click save. And make sure that in your subdirectory you have this new file. Well, you can already close the JMOL. And if you didn't use ampersand, you can just go to command line and push Control C. It will, or hit exit here. So backspace, backspace, backspace. ls minus, and look for this more titanium 4.xyz. More, look in more titanium 4.xyz. Enter. Okay, for titanium 8 oxygens, total 12. Okay, good. Please stop sharing. And I believe we need to Lina and then back Kea. Lina, are you on the line?
Yeah.
Will you please share screen?
Yeah, sure. So this is the 6 titanium atoms. And
so I think 4 will be sufficient. You can do 6, but then you will be different from the rest of the class. So
okay, so can I delete 16 yes. and 1? Or
yes, you
or,
can.
Or 15.
You can.
16
it doesn't matter from each side. Just
okay.
delete.
So I will delete 16 and 15 and atom 5 and 6, and then save it with CHEM4. Okay.
Yes.
Okay, do that.
And if you keep doing, but if you're unsure, you can save coordinates after you delete each of the atoms. Like if you're really worried.
Oh, okay.
Yes. Yes.
Okay, so we need to measure distance between
no, you already measured the distance.
Yeah, I measured the distance. It was between 5 atoms, was 10.8, similar to...
Yes, good. And now save into your directory. Save as.
Okay, let's save it.
Select some unique name. Okay.
Okay, I save it.
Okay, yeah, I think it is. You are good. You can stop sharing.
Okay, thanks.
And now you stop sharing, and Kea, please start sharing.
Okay, just a minute, person. Okay.
Boston, how things are going for you? Okay.
Share. Yeah, desktop, everything. Okay, share. Let me go. Actually, my laptop stopped working. That's why I'm started to using my office laptop. Sorry, office desktop. So,
drag and move a little to change the angle.
Change the angle?
No, not here. Just in this window, yes.
Okay.
Enough. Now measure the distance between number 1 and number 15. Measure distance.
And there is one problem, Professor, that I was in hurry and I was not able to copy a file from your folder. Now
Don't worry. The file that you have,
directory.
Whatever you have is good. So click number 1, click number 15.
Yes.
Add to measurement list.
Yeah, I already wrote.
Record this number somewhere in your.
Yeah, I already wrote.
Okay, now click cancel. Select red cross under the word X. Yeah, here, and remove atom number 15. Click 19, 17, and now save this file into your directory. Save as.
But.
Save as, and now make sure that you are saving in your directory.
How to go to my directory? Scratch.
Wait, no.
Okay.
Click cancel. Click cancel. It will be quicker. File. Save as.
Okay.
And now slowly.
Okay, slowly.
So click on this CHEM676.
Okay.
Double click. On the symbol of folder, not on the text, but on the symbol of folder. Yes, double click. Yes, 2021.
Then Kia.
Yeah.
Then this. Okay.
And call it something like titanium 4 ti4.xyz.
ti4. Then
.xyz. Period. XYZ. And uncheck use file extension. And click save. Okay, I think you're done. You can stop sharing. I'll quickly check with Boston and then continue the demonstration. Yes. So now I will start sharing. And I do not need the GMO anymore. I can go back to the command line. So I'm closing it, go into command line. And here is the file that I have created. More titanium 4 XYZ. So there is right now here titanium, there are 3 titaniums at the top and 1 at the bottom. For Gaussian it will be not a problem, but WASP will punish me if I do it. So I need to reorder files. So I do command sort, then give the file name, and do bigger into and name it as postcar.xyz. Let me copy this command into the chat line.
So this is alphabetic sorting that occurs?
Yes, it's alphabetic sorting. Yes, I knew that. And now I open this file with vi postcar.xyz, and I see that something is out. The ordering is okay, but first line is empty, which I do not like, and WASP will not like. I need to do vd, and then 12 is number of atoms. I type I to start inserting and add empty line. And after that, I do escape, (WQ) to save. Now I check more postcar.xyz. And now the file is satisfactory for me and hopefully for WASP. So now I'm starting to offer some unique commands which are work really well, but they are not like part of the vast software. They are homegrown. So there will be two commands. First is rotate _ XYZ. So you type this. Let me copy it to the chat line. Please. And after it will ask me angles. I will put 0, enter, 0, enter, 0, enter. So if my model will be not aligned along x-axis, through this command I can realign it. And if you open the code, it just practices three-dimensional rotation as some of us were doing in like classical mechanics. Rotate XYZ.
It seems that you are copy the.
Oh, I was answering. So let's make agreement. If there are no big secrets, let's just share all messages to everyone. It will be much quicker, much better. So sorry, let me copy once again. So first you do sort, and then you modify, and then you do rotate. So after you practice this rotate command, there will be new file in the format of so-called tinker command. Some of you who practice force field molecular dynamics can be aware of it, but for most of us it is not needed. And let me go to the next step. I will revisit this step if needed, but it seems straightforward. You just type 0, enter, 0, enter, 0, enter. And now I type tink to wasp _, so I repeat this highlighted stuff, and then type 0, 0, 0. Copy, paste this command into chat line. Copy, paste. And after I hit enter, it creates ls-lt. It creates a file named postcard. This is good. The file postcard will be in the right format, but it is not yet ready. It is not yet ready. And when we no, I don't need this. So this command takes the file that we have created by rotation and convert it into the postcard file, which is a desired format for the last problem. Then it adds, we put 3 arguments at the end. These 3 arguments, and now let me attract the attention, it is a continuation of the most complicated subject in today's meeting and in the next month. Those 3 numbers are amount of vacuum in x, y, and z direction that we add to our box. So to connect, not to my words, but to your words, it is what Lina told, that one needs to leave space between periodic boxes, which is equal to the bond length. You remember, right? So if I add 0 amount of vacuum, it will be predominantly wrong. It means there will be no space for bonds, which means it's like a sportsman or soldiers lined up really close to each other, shoulder to shoulder, which is not correct. There should be a little space. And we are going to fix it and put correct amount of artificial vacuum in X, Y, and Z direction. And the rest of all exercises in class is done by anyone who finishes this class with guarantee. And this little exercise, although it is really important, sometimes was missed in the past. So I invite you to concentrate and try to follow. Maybe I'm not delivering it in right, so try to use your creative thinking to follow. But it is really important. So I need to put some different numbers. So, and specifically, most important, I need to put correct number along x-axis, because as you saw, our titanium dioxide polymer is growing along x-axis, right? And we were measuring the size of cell along x-axis, which in your calculations was around 10.8. So when I hit enter here, it gives me length along x, length along y, length along z. So, or if I type head, it shows the box 3 by 3 that I was telling to you, that shows size of the cell, and along x-axis is 9.45, right? So right now, and I invite you to be mostly concentrated specifically. Right now, when I was practicing predominantly wrong command, when I was adding 0 amount of vacuum in x direction, the size of the periodic cell in x direction was 9.45. But according to your measurements, it should be 10.81, right? So we need to select such number here that will convert this number into 10.81. Make sense? Please confirm if it is okay or if you need more explanation. Lola? Good. Let me check. Lina?
I couldn't understand what's the last point. I didn't follow.
So you need more explanation?
Yes, please.
Okay. So maybe I'll do a little experiment. So I want you to see correlation between what I put right after the word postcard here and what I'm getting in there. So if I put number 1, can you guess what will be the result? Lina?
Yes, doctor.
So I'm putting number 1 of amount of vacuum, 1 angstrom. What will be the cell size? So I guess it will be this 9.45 plus
so
1.
This is for 100 and
yes.
44010 then?
So see, if we get to the 10.45, right? And if I watch this postcard file, now it is a little bit better, 10.45. But we need good question, but still a couple of words on that. But here we need 10.81, right?
Yeah.
So instead of putting the amount of vacuum of 1, we need some other number. 10.3. It's almost good, right? If I put 10.35, it's almost what we need. But right now, I am going, how to say in a respectful way, the empirical pathway. I'm just doing several probes, but we can do it in a smart way. So, how to change? Here, let me write it as an equation. So we have A plus B equals our C must be 10.81, right? Our A is 9.47. The question is, what will be the value of B? So we need to subtract, right? So B equals 10.81 minus 9.40. Make sense? So I'm going to practice this exercise in the command line. So there is a calculator in the command line which is called board calculator, and I type the number that I really want. So please dictate me. What was it? 10.81, right? Minus, and now I put whatever I'm getting with 0 correction. Paste. So the correction is 1.3353. And now I exit this board calculator by quit. And now I do 353. So now the size of the cell in X direction is 10.81. Make sense? And for Y and Z, we do not have chemical bonds, but we need to avoid interaction between references. So ideally, I should put infinity. But if you screw up all my calculations, we will do it too expensive. So I replace infinity by some number which is bigger than bond lengths, 2 or 3 bond lengths. So like 7 angstrom will be sufficient. If you prepare data for publication, you can put like 8 or 10 or even more 15, but bigger than that you do not need, because bonds are decreasing exponentially.
There's a larger separation in those that will have increased computation time.
Yes, substantial. So if I replace this like by 6 and 6, then now the simulation cell is 10.81 in X, 10 in Y, 10 in Z. And the numbers here, so letters tell that we start with oxygens and continue with titanium. Oxygens, there are 8 oxygens. Titanium, there are 4 titanium. And if I look for the whole file, not head but more. So first 8 records. 2, 3, 4, 5, 6, 7, 8. Those are coordinates of oxygen. Next 4 atoms are coordinates of titanium. Right? So I would like everyone to arrive to such file. So I will first walk in the class and then ask everyone to share screen.
Dr.
So,
Kirin,
yes?
may I have a question?
Yes, please.
I didn't get your explanation about, for instance, here the system is stretched in the x direction, okay? So you put the lattice or the cell size in the y and z, in y and z around 10. So does it affect the result, for instance, if it is 10, 8, or 15, or something like that? How important are they? So actually the cross-section area of the cell.
The amount of vacuum in X and Y will slightly, if you increase the amount of vacuum, your results will be more and more precise. If you decrease it maybe up to 5, the results still will have qualitatively correct. If you make it shorter than 5, so basically shorter than 2 bond lengths, it will start forming bonds between periodic images and results will start being wrong.
Yeah, I got your point. We just don't want to atoms past the periodic boundaries. But for instance,
we do not want atoms to be close enough across periodic boundaries. We want them to be separated.
Yeah, I got your point. So maybe, for instance, if we put cell size in that direction, for instance, 8 angstrom is enough, okay? Yes. What would happen if I put it not 8, 20?
It will be, the results will be a little bit better, but the calculation time will be about 10 times longer.
Oh, it will increase the simulation time.
Yes.
Okay, I got your point. Thank you.
Make sense?
Yeah.
Okay, so please, everyone, try to arrive to such file, and I'll make sure that everyone is able. Okay. Yes. That's okay. That's okay. Yes. which is the number of students, then space, and then now it is a dual function. It was not aligned along the axis to the aligned. Yes, you can. It just rotates more along axis. And even if you do not need to rotate, it will change format. Rotate and enter, now hit 0, enter, 0, enter, 0. 0, enter. Not space, enter. Oh, okay. Zero, enter, 0, enter, 0. So we have okay. So this is new, so name of the file that you need is 0. So size for we need to because it's your free will. Later on, you can make an experiment with different numbers and see how the result is. If it is bigger than 5, that's not the correction. Okay, now the same style. No, those are coordinates. First coordinate is x, second is y, third is t means we allow atoms to be conserved. Sometimes one can squeeze part of atoms and cause differently. It will be a reaction. For example, you need to freeze catalyst and react to I see something in the chat line. Yeah, well, after we are done with the lab, it will be recorded and you can try to practice it. So let me ask you to share screen one by one. So Sarah, would you like to share screen?
Yes. Yeah, Professor, this is my XYZ file, and it is, I think, it has the
It's good. It's good. Don't worry. Don't worry. Type PWD just in case. Let me share where you are. Enter. Now type copy CP space T name of your file. No, test. You called it test. Test.xyz. Space, and then with uppercase postcar.xyz. Postcar.xyz. Enter. Now type rotate with lowercase. Rotate underscore uppercase XYZ. XYZ. Enter. 0, enter. 0, enter. 0, enter. Now, so no errors, good. Now type ls-lt just to check your files. Enter. So you see last file is postcar underscore rot underscore tink xyz. We will use this file name. Now please type TINK lowercase TIN, not L but N, and not M but N, like Nebraska. K, and now hit tabular that it continues. Tab, but yes. Now copy this name of the file, postcar underscore, yeah, this file, yes. Now space. Now type postcar with uppercase. Postcar space 0 space 0 space 0. Enter. Now you see lattice vector number 1, 9.445, right?
Yes.
So now BC, yes. Type the number that you have recorded minus, and then this number that you actually see, 9.445. Enter. And now type quit to stop the calculator. Quit. And now arrow up and replace first 0 with this number 1.376. And the remaining 2 zeros replace them with number with 6. 6 and 6. Enter. And now type more space postcard. Enter. So it seems you're done, right?
Thank you.
Okay. Yeah, very good.
Thank you.
So you can stop sharing screen. Steven, would you like to share your screen?
Wrong button. So I got an error.
Okay. Let's type rotate underscore XYZ. Enter. 0, enter, 0, enter, 0, enter. No, not space. And Control C to stop it. Control C. Control C. And, arrow up. Enter. Enter. 0. Enter. 0. Enter. 0. Enter. So it gives error. So file postcard.xyz is not found. Please do ls space minus lt. Now let's do more postcard.xyz. Enter. So we need to slightly modify it. Type vi space postcard.xyz. Enter. So dd, two letters D. Now I arrow down, enter. No, arrow up, just to add a space between 12 and the O. One arrow up more, not space, but enter. Yes, and now escape column WQ to save the file. And now arrow up to try rotate several times, rotate once again. Enter. 0, enter. 0, enter. 0, enter. Now we do not have an error. Now let's do arrows up until you see the sting to last. But yeah, enter. So you see this 9.439. So please type BC or enter. Type the number that you got by measuring size of the cell. Minus this 9.4 point. Enter. And now quit. Type quit. And now arrow up 2 times. And replace first 0 by the number that you got from this subtraction, 1.376. And replace last 2 zeros with numbers with 6 and 6. Enter. More space, uppercase postcard. And enter. No period, no XYZ, just postcard. Enter. So you're good to go. Everything is correct. You can stop sharing. So Amira, I hope it is okay if you skip. So Kea, would you like to share screen? Kea, are you trying to share screen?
Yeah, I'm trying to share a screen. Actually, I was trying to do the same thing from the beginning. And that's why.
Okay, so let's type more postcard.xyz.
Just a minute, Professor. More
space postcard.xyz. Enter.
Yeah.
Okay. Now do vi space postcard.xyz.
VI.
VI. Space postcard.xyz. Enter. Now it looks like we are missing the space between 12 and 0. So type DD.
Type DD. Okay.
Can you scroll up a little?
Yes. Okay.
Now type I.
I.
Go up. I.
Inside.
Now arrow up. Arrow up several times. Stop. Arrow down.
Down.
Now hit up. You should be just on the first oxygen. Up. Arrow up. Type arrow down. Stop. Now hit enter. Now let's save and exit. So escape column WQ.
Escape then?
Then column WQ, same as we always save files in DI editor.
Okay, yes, I understand. WQ. What?
Escape, then column, this 2 dots, one under shift
escape.
column.
Why it's not working? Escape 2:W.
WQ. Good. Enter. Now type rotate.
Rotate.
Underscore. No, not space, but okay. Underscore. Uppercase XYZ. Enter. 0. Enter.
0.
0. Enter. 0. Enter.
Yeah, it's just some error.
Let's type more space postcard.xyz.
Postcard.xyz.
Now it looks reasonable. Now let's arrow up. Just repeat once again. Arrow up. Enter. Until you get rotate.xyz. No. Escape.
Escape. Just a minute. Escape. It's not working from here. I don't know why it's not working. Escape.
Just hit the button confidently.
Yeah.
And then escape and then shift column.
No, I don't know why it's not working.
Okay, if it doesn't work, just open another tab. If it is blocked, yeah, here, and reconnect back to the same thing. And while you are connecting, please stop sharing. I'll talk to Lina and then we'll return to you. Lina, would you like to share your screen?
Yes, sure.
Yeah, thank you.
So,
and I apologize, we'll take a few minutes longer, but we are very, very close to the end. We did the most complicated part and the rest will be just automatic. So,
so here, I think I have an...
no. Lina, rotation didn't work for you. It gave an error. You see at line 91 of the file, end of file. So let's open postcard.xyz vi space space postcard.xyz. Enter. Arrow type dd to go to the very top. Go to the very top.
Okay.
Very, very top. Empty line at the top.
Okay.
Now we need to delete this line by typing letter D two times. DD.
Yeah.
Okay. Now type letter I.
I.
To go to insert mode. Now arrow down once. And now hit enter. And now save and exit. Escape column WQ. Enter.
So, Doctor, what we
enter. Hit enter. So, what's your question?
Why we changed the location of the oxygen? Like that's me and Kaya. We did the same thing. What's the issue before?
I'll explain later, but it is a convention. So, West wants elements to be alphabetically ordered. Otherwise, it will have problems.
Okay.
So now let's type rotate or type arrow up. Yeah, enter. 0, enter. 0, enter. 0, enter. Good, no errors. Now arrow up to see your hit enter.
Okay.
Okay, is it 10.7?
It's
8
10.79.
Okay, hit arrow up.
Okay.
Remove this 1.35 by 0, replace it by 0.
Okay.
0. Enter. Now type BC. Enter. Type the number, the size of the cell.
Yeah, I got this number, I think.
Okay, minus, and then this 9.4.
439.
Enter.
Then click.
Arrow up 2 times.
Okay.
No, arrow up. And now replace first 0 by the number that you've got from this calculation, 377. And arrow up once again.
Maybe increase it a
But
little.
no, you need to literally put your answer 1.377. No. When see when you did subtraction in your board calculator.
It was 1.377.
Yes, exactly.
Okay, so we need to put 377.
Yes, correct.
Okay.
Do arrow up once again, and replace last zeros with 6. 6. Enter. Now do more space postcard. Enter.
Without the
Enter. Without anything else. So you are good to go. You can stop sharing.
Okay, thank you.
Kea, would you like to share screen?
Yes, just a minute.
So after I'm done with Kea, I will do demonstration for like 5 minutes and we will be done. I know that, sorry for holding you longer, you may have plans, but the rest will be straightforward, without challenges.
Yeah, this is the thing. Okay. So,
once more, 0, enter.
0 again.
0, type 0.
Oh, just a minute, Professor. 0, then enter. Again error.
So let's do more space postcard.xyz. Pause. Enter. You did remove last 3 titanium atoms.
Yes, I did.
Which is bad.
Okay.
Type ls space minus lt. We'll fix it together. Not okay. Just show me ls, not less, but ls. ls space minus lt.
Minus lt.
Enter. So let's repeat over. Let's remove postcard.xyz. rm space postcard.xyz.
.xyz.
Enter.
Yes.
Sort sort.
SORT.
Sort space ti4.xyz.
ti4.
No, the file that you see here.
Okay. I can understand. ti4.xyz.
Space.
Enter.
Space.
Space.
Bigger. Bigger. The caret. The angular bracket. Bigger.
Oh.
Space.
Space.
Postcard with uppercase. Postcard.xyz.
Postcard.xyz.
Enter. VI space postcard.xyz.
What?
VI, we need to
DI.
edit it. VI. Not D, but VI for visual edit. Not B, but V. We need
VI.
yes, correct. VI, correct. VI postcard.xyz.
Enter.
Enter. Arrow up. Let's go to the top of the file. Arrow up, arrow up, arrow up.
In there.
Arrow up once again to the very top, to this
Okay.
empty line.
Okay.
Now type DD.
DD.
Now type I for insert mode.
I. Yes.
Arrow down once.
There.
Not twice. Enter.
Enter.
And now escape column WQ.
Yes. W.
WQ. Enter.
Enter.
Now rotate and type or hit rotate underscore.
Capital letter X, Y, Z.
Correct. Enter.
Enter.
Zero. Enter.
0.
0. Enter.
0.
Yes. Enter.
Now it's what? What happened?
Now tink to wasp. TINK, and then now hit tabular. It will continue. Hit tabular button. It will tink to wasp underscore. Hit tabular yes. WAT.pl.
PL, then postcard. POSKCAR. Postcard.
Underscore.
ROT. Then underscore.
Hit tab button so that it continues.
Okay.
You know where is the tab button? It's to the left from the letter Q.
Okay.
Yes. Now type postcard uppercase. Postcard.
Postcard.
Space.
0.
0 space 0 space 0.
0. Yeah.
Enter. Now type BC.
What?
B.
B.
Like brain. C like capital. Enter.
Enter.
Enter. Now type the number that you wrote on the piece of paper.
Okay. 10.821.
Minus.
Minus. I know that I wrote something there. Minus 9 point.
Yes.
9.43.
445.
Okay, 445. Okay. Then enter.
Quit.
I need to write quit.
Quit.
Okay. Then enter.
Enter.
Okay.
Arrow up. Arrow up. And now replace first 0 with the number that you got in this little mathematical exercise.
1.376.
And then replace last 2 zeros with 6 and 6.
Okay. This one 6. This one should be 6.
Enter.
Enter.
More space postcard.
Space postcard.
Enter.
Enter.
Okay, you're good to go. Now you can stop sharing.
Thank you, Professor.
Oh, my pleasure.
Thank you so much.
And let's quickly finish it. Maybe we'll not do the round of checking. I will just do demonstration and then we'll continue. So after I do have the postcard file ready, I need 3 additional files. I copy them from template. So first copy tilde bin in car transition here and as the in car. So I let me copy this. Copy into chat line. Can anyone send a little message to chat line, because the window did disappear for me.
Okay.
Just blank, hit enter once in the chat line.
Sarah already said.
Oh, okay. Good, thank you. Paste. So this was a command to create in-car file. Now the template for key points, I take it from the same source. Copy. Chat line, paste. And then I need potentials that define types of elements. So first element is oxygen, second element is titanium. The potentials are stored in the following directives: CAT from concatenate, tilde POT PBE, oxygen slash pod car, bigger pod car. Enter, and let me copy it to everyone. Copy. Enter. Huh?
You don't need the first line. You want before the yes or no?
No, I typed no. And then second element is titanium. Okay.
Oh, excuse me, Professor. Can you the comment cat tilde pot pb pot pop underscore pb?
So you want me to explain what this command means?
No, in the chat line, because you didn't copy it in the chat box.
I did.
The one before the yes or no is not in the chat line.
Yes, before yes or no.
Oh, no, you do not need it. It did appear when I was hitting the tab button. It was trying to give me 270 options, which I told I do not need.
Okay.
So now I type ls minus lt, and I do have, you see, files. I have 4 files that I need: postcar, podcar, in-car, and key points.
Yes.
If I want to check if my podcar is correct, I do grep pbe podcar, and it shows that there is oxygen and there is a titanium, 2 elements. If I did errors, then it will be one of these records will be missing, or there will be more than 2 elements, but now it is good. And now I type bin wasp photon and hit enter. So let me copy the command, copy, in the chat line, paste. So basically it is done, and if you the calculation will be, since it is quite simple, it will be done very soon. So you see here are the iterations. So it tries to approximate electronic structure again and again until it gets to convergence. And the procedure for DFT and for hard code is very similar. Through this convergence protocol, we'll go over on Friday. Yes, Austin?
So when you set this running, can you exit automobile experiment and go run it?
Oh yes. But right now I just rush because we are 20 minutes longer than needed. So this procedure goes until the number in here will become smaller than 10 to the minus 5, and it should converge. Yeah, it's about to converge. And now it tells running away functions, which means it is done. So if I type ls minus lt at this point, ls minus lt at this point, so you remember before my files ended here, and now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 new files, right? Those are output files, and most important in them is outcar. So outcar is analog of .log file in the Gaussian. So I type more outcar, and let me copy it here. Copy. And then I just scroll about to the end of this file. So it will be like 80% of the file. Scroll. And at some point, I will recognize the records that here. So it starts with Fermi energy, and then you see the table of orbitals. So it's about 84%. And if you can come to this table, it means you have successfully completed what you needed to do. So, did you get it?
I missed it.
Okay. So, if you need to depart, if your time is up, feel free to depart. The record will be hopefully available. And if you want, I can browse around, but it's by your free view. I already apologize for taking an additional 25 minutes of your time. If you want, I'll stop by and help. But if you need to go, feel free to disconnect or depart.
Thank you, Professor. I'll see you tomorrow.
Yeah, thank you, Steven. See you tomorrow. I'll take details in this.
Thanks, Dr. Kellen. Have a good night. Bye.
Goodbye. Stop sharing. So I see Sarah, Amir, Kea.
No, I'm leaving because I have 2 laptops. I'm already leave from one, then I will leave from another. Just
Okay. So yeah, I think it's time to finish. If Sarah, if you want me to look at your screen, you can share. But if you are confident, we can finish now.
It's okay. I get the results that you got. Thank you.
Okay. Yeah.
Well, I have 2 questions if you have time.
Please. Oh, please. So let me double check that.
Yeah, at the end of the session.
Yeah, you don't have questions, right?
No.
Okay. So Amir, is your turn?
First question, Dr. Kinney, is about podcar file. If I have a podcar file, for instance, for conjugated polymer, okay, I want to repeat the calculation for another polymer, organic material, which atom types are the same. Usually, this podcar is the same for all materials that include same type of the atoms.
Yes.
Okay, and where is the library or source of this podcar file? Because when I check VAST Wiki, they do not offer the a data set for podcars.
So today I was showing directory for podcar contributions on the photon, and when we meet next time in next week lab, I'll show location of these potentials on the NERSC computer.
Okay, so when you compile the VASP, they already included as a library, right?
So VASP is expensive commercial code, and therefore they do not give components in the open access.
No, I know. When okay,
so
when you have the license,
when you purchase new version, you get the source code to compile and copy of the podcasts that you place on your computer wherever you like.
Okay. So this bin directory usually is provided by VASP for people who purchase.
They allow you to download the files and then you place it in your computer wherever you like.
Okay, I got it. And the second question was a tiny question about you use a Perl script thing to VASP. The script that you write it or no?
I contributed to writing the script, but it was like effort of several people. There are this script is quite old. It's maybe written in 2005, but there are more modern scripts that also convert from, let's say, XYZ to postcard, but they have less options to tune the details.
Yeah, I saw them. I checked also before, for instance, Vesta or Material Studio maybe provide some service to give you the postcard file, but the way that you use this, I think that is more interesting for me.
It gives you option to create models yourself and modify them. The easiest way is when you have crystallography data. If you are modeling the material that is possible to crystallize, if it is like periodic solid or a polymer that takes crystal shape, then there are scripts that literally convert .cif files into postcard.
Yeah, because there is a periodic lag in those models.